Let's talk about head and pressure. The head is the height above what they're measuring, which is the datum, the head, and the pressure is what's exerted at the bottom. So the head is in metres and the pressure is normally related to bars. So this formula here, H equals 10.19p, or you can transpose that depending on what you to work out, is P equals 0.09981 times the H. And don't forget, pressure is bar and H is height. The best way to explain this is by using an example. Determine the standing pressure at a tap located in a water tank 30 metres high. Well, this is the formula here. You put it in, P equals 0.0981 times the height. You put it in, the pressure would be at the bottom, a tap would be 2.943 bar. So that's what that reading would be on that tap, based on the height of where the water is. Let's do another example. Determine the pressure of the water from a tank located 35 metres above the ground. You put them in this formula here, you get 3.43 bar. So if the water was located and the top of the water is 35 metres above the ground, 35 metres, so the height from the top to where the tap is 35 metres, it would register 3.43 bars on the pressure gauge. Let's do another example. A pump is supplying water to a dry riser in a building 59 metres high at 5 bar. Will water be flowing? So if you've got a dry riser 59 metres high, dry riser 59 metres high, and the pump is showing 5 bar, ignoring frictional loss, just ignore for the principle of this. Well, firstly, you need to know the pressure required to raise the water 59 metres, and this is the formula. P equals 0.0981 times the height, and it comes out at 5.7879 bar. So you need 5.7879 bar without ignoring friction just to get the water to that height. And it's only running at 5 bar. So what's the answer? In this case, the pressure's not sufficient to raise the water up there, and there will be no flow. It will not be flowing. It wouldn't work. That's not going to work. So in this case, there would be no flow. That's why they have risers in buildings over 60 metres. Because it takes at least 5, nearly 6 bar, just to get the water from the pump to the top. So that's why over 60 metres buildings have wet risers in there. That's why they have wet risers. Now, don't forget when we talk about pressure, the atmospheric pressure, at sea level, atmospheric pressure is 101,300 pascals, which is Newton metre squared. So that's the SI unit for pressure. Pascals or Newton metre squared. So that's 101,300, where a bar, because we work in bars in the fire brigade, is 100,000 pascals. So 1 atmosphere is 101,300, that's at sea level, the pressure, atmospheric pressure, and 1 bar is 100,000. So that's the principle of head and pressure.